So this question here, B3, the first part A, they want you to plot the velocity against the time. In other words, a velocity time graph. So here's my table, which I retyped. So if I just put in the graph for you, insert chart line, scatter with the points connected. Don't do that. This is 2013 B3. The x-axis is time in seconds, and the y-axis is something was wrong there. The next axis is velocity in meters per second. Okay, so I just where's my zoom out button gone? There we go. So that's what they want for 4 marks. So I mean, that should be 4 marks for everybody. Part 2 is use the graph to calculate the acceleration at the start. So on a graph, what's acceleration? It's the slope. So if I look at this triangle, how high is this triangle? It's 12 high, and how big is the base? 15. So for part 2, the acceleration, which equals the slope, which equals the height over the base, which is 12 over 15. 0.8 meters per second squared. Alright, part 3 is what is the deceleration. So the deceleration is the acceleration at the end when it's negative here. So the same deal, it would be 12 over 10. So the d would equal the slope, but they don't want the minus in it because the d in deceleration already means that. Sorry, what is it? 12 over 10, is it? So 1.2 meters per second squared. What's the total distance? So the distance is the area. Yeah. So the first area is a triangle, which is a half 15 by 12. Then the second one is a rectangle of 10 by 12. And then finally is another triangle of a half 10 by 12. So let's see now, 6 by 15 plus 120 plus 5 by 12. So 270?
Yes.
Yeah, okay. And then finally for this part is what is the maximum momentum. So the momentum is mass by velocity, and the mass we're told is 980. And what's the maximum velocity? 12. So it is 11760 kilogram meters per second. 6, 7, 8, 9, 10, 11 marks for all of that. So I mean, that's very generous. Okay, so now I think the B one is where it gets tricky. No, you don't always get it. So if you do get it, make sure you get full marks, don't screw it up. I'm not saying you would, Joshua, just saying don't. Okay, try the B part now. For look at it. So the B part here, you got plank of wood, and there's a mass of the plank of wood is 3 meters long, and its mass is 4 kilograms. So there's a 4G here, and then this distance is 1.5, and then this distance here is 1.5 meters, of course. There's 2 supports, C and D, and it's 1 meter. Yeah, so let's see, let me just draw that in. So there's a support here going up, which I'll call R, and then there's a support here going up, which I'll call S. And the distance from here to here is 1 meter, and the distance from here to here is 0.5 meters, and of course the distance in between is 1.5 meters. And also there is a mass of 8 kilograms placed here, and this is 8 kilograms, so down here is an 8G, and then the distance here, I'll put it in red so you can see it, this distance is 1.6. Yes? Hey, you looking for someone? You're looking for a room, yeah? Yeah. Okay. So what do they want first here? This support at C and support at D. So in other words, they want the O and the S here. So we can make 2 equations. The first equation is O plus S equals 12G. That's the first one. Okay. R plus S equals 12G. And then the second one we can use is turning forces. So what point should we use as our turning point?
Or C? D?
Well, I mean, we can use A, we can use B, we could use a point where C is, point where D is. And I actually think, I usually use this point here, but I think it's okay. I mean, I know it's okay to use this point. I think we'll be a little quicker if we use this point here. I'm just going to find both at the same time. Okay, so if I use this turning point, firstly, this one here, is it clockwise or anti-clockwise? Clockwise, isn't it? So that would be 4G, and what's the distance to it? From here to here, what is it? Come on. From here to here. 0.5, thank you. Okay. Now this next one, it's also clockwise, so it's 8G. And what's the distance? 0.6, yep. And then this last one here is anti-clockwise. The distance to it is, let me see, here to here is 1, so there's 2 at the left. Is it 1.5? I think it's 1.5 from here. Oh yeah, sure. There it is right there, 1.5. 1.5 times S. So there you go. There's our 2 equations. So we can get our answers. 4 times 9.81 times 0.5 plus 8 times 9.81 times 0.6 divided by 1.5. So I get F equals 44.5 newtons, and then R equals 73.2 newtons. The object is gradually pushed towards A. Determine the distance when it just begins to lose. Okay, so what they're saying in the last part is you start pushing the block to the left until the beam is no longer supported by D. So what's special about this point in time when the beam is no longer supported at D? What's 0? The S is 0. So in other words, what they're saying is find the distance x so that S is 0. So my two equations are the same, except instead of having, what distance was this here? 0.6, wasn't it? Instead of having 0.6, I'll have x, and instead of having s, I'll have 0. So now I get or equals 12g, and then 4g times 0.5 plus 8gx equals 0. So I can get what the x is. Something went wrong here. My x is negative. Oh yeah, no, it could be negative, yeah, because then that would just mean it's before the point, yeah. No need to panic. 4 times 9.81 times 0.5 divided by 8g. So I got x equals minus 0.25. So what that means is it needs to be here. 0.25 from this point, which means from the end it's 0.75.
The S? That's the S?
Here?
Yeah.
They want you
No, I mean the 0.75 from that.
from the
Is
A.
that S should be?
S should be.
The block is 0.75 from A.
Yeah, the block is 0.75 from A because my answer minus 0.25 puts it to the left of this point here, my turning point. So the answer is 0.75 meters from A.
Did you use F versus turning point?
I used the same turning point, C. How did I get 0.75? Well, are you happy with how I got the minus 0.25? So that minus 0.25 means the block is 0.25 to the left of the turning point. On the turning point, I'm using the same turning point. No, yeah, that's fine, don't believe me, that's alright. What number is this? 2013 B3 2013 version 2 Martin scheme B3, the last part. Whoop. I think you owe me an apology. No, it's alright. Yeah. So in fact they did exactly the same way I did as well. They used the same turning point, I mean. By the way, I'd also say here, they said alternatively students could take moments about support C. That's exactly what I did. I think in their answer here, they took it from A. Does that what it looks like they took it from A? Or maybe they took it from D. Either way, you have A or C as the two places I'd use. Yeah, that just gives us that equation here. But they need this second equation as a turning force equation. They use D. That's fine. Oh yeah, of course, because they're going to do it in order. So they want to get the other answer first. Yeah. Okay, so that's 3 taken care of. I don't think that question was too difficult, really. I mean, it's not so bad. What I'd like you to do next is number 5, which is a wave question. So if you can try number 5 next. What's wrong?